170,000 terawatt hours. That is how much energy humanity consumes globally every single day. It is a literally incomprehensible amount of power keeping our modern world spinning. Welcome to This Explainer, where we are going to look at the massive system upgrade required to take our world from fossil 1.0 to a sustainable clean energy 2.0. Today, we're unpacking a master blueprint for the future of clean power and figuring out how a net zero world actually functions at scale.
So, what exactly happens when the engine of the world runs out of fuel? Well, to answer that, we have to recognize that the current crisis of our energy reliance isn't just an emissions problem. It's a massive economics and stability problem. The foundational pillars of coal, oil, and gas carry huge systemic vulnerabilities. We're talking about stranded assets, highly volatile global supply chains, and the constantly increasing marginal costs of extraction. When the global economy is shackled to energy sources that are not only dangerously polluting but economically unsustainable, upgrading to a new engine isn't optional. It's an existential requirement. All right, here is our blueprint for today. First, the global energy crisis. 2, the clean energy arsenal. 3, storage and smart grids. And 4, mapping out the net zero future. Let's get into it.
Starting with Part 1, the global energy crisis. Let's look at why a complete system overhaul is absolutely mandatory.
Think about our traditional fossil fuel model for a second. It is heavily burdened by wild price volatility and costs that just keep creeping up. Extraction gets harder, right? And it gets way more expensive over time, passing that financial strain directly to global markets while at the same time driving unprecedented climate change. But look at the clean energy model. It operates on a deflationary technology curve. Because we're shifting from extracting finite resources to manufacturing advanced tech, the cost of renewables continues to plummet. We are basically trading limited, increasingly pricey pollution for unlimited, increasingly affordable clean power. It's a total paradigm shift. Moving right along to Part 2, the clean energy arsenal. Let's take a look at the actual technological solutions we have at our fingertips.
Now, figuring out this clean energy hierarchy means we have to be real about the inherent trade-offs. Solar and wind, they give us incredibly cheap marginal generation. But the sun goes down and the wind stops blowing. We have to solve for that intermittency and the fact that wind requires very specific geographic locations to maximize output. Then on the other end of the spectrum, you have nuclear energy. It is an absolute powerhouse, offering phenomenal low-emission baseload power around the clock. But setting it up means dealing with intense regulatory frameworks, massive upfront capital costs, and long-term waste disposal. The real secret to success here is balancing all of these factors to keep the grid perfectly resilient.
If you want to see this working at an absolute mega scale, look no further than India, specifically the Bhadla Solar Park. We are talking over 14,000 acres. It's essentially a sea of solar panels and one of the largest installations on the planet. By aggressively scaling up these massive utility-scale parks, India has driven their cost of solar power down to historic lows. It is totally rewriting their national energy economics, proving that rapidly growing economies can literally just skip the fossil-heavy phase and jump straight into high-capacity renewables.
You've probably heard hydrogen hailed as a silver bullet for the energy transition, right? Well, there's a huge catch. Color matters. You have to clearly separate pure electrolysis-driven green hydrogen from what's known as gray hydrogen. Green hydrogen splits water molecules using renewable electricity, giving us a completely zero-emission fuel that is absolutely perfect for heavy industry and shipping. But gray hydrogen? That's extracted using natural gas. It's basically fossil fuels hiding behind a new name. For true decarbonization, we have to scale the green variant, and only the green variant. All right, on to Part 3, storage and smart grids. It's time to explore the energy control systems making this all possible. Since wind and solar are intermittent, catching and holding onto that power is just as crucial as generating it in the first place. Now, massive grid-scale lithium-ion batteries get all the headlines, but you know what the actual workhorse of global energy storage is? Pumped hydro. It literally pumps water up a hill into a reservoir when power is cheap, and then just lets it flow back down through a turbine when demand spikes. It makes up over 90% of global grid storage today. Combine that with emerging long-term hydrogen storage, and you've got giant planetary-scale shock absorbers for our power supply.
Now imagine an AI-powered smart grid as an invisible conductor, orchestrating this whole complex system in real time. The old grid was dumb. It just pushed power in one direction. But modern AI control systems, they analyze micro-fluctuations in power demand down to the exact millisecond. It knows when a massive factory is about to spin up or when thousands of people are going to plug in their EVs at the exact same time.
By perfectly routing a balanced supply to exactly where it's needed, it virtually eliminates wasted energy.
Finally, let's hit part 4, the net zero future. How do we actually map out this massive energy transition?
So the huge task of global decarbonization relies on a highly structured, phased rollout. Phase 1 is all about the aggressive reduction of our legacy fossil fuel systems. Phase 2 drastically ramps up our renewable generation and smart grid deployments. And then Phase 3 brings us to that fully balanced net zero state. But let's be real, trying to overlap these phases without triggering massive economic shocks or energy shortages, that is the ultimate geopolitical tightrope walk. It takes flawless timing to decommission the old engine while the new one is still spinning up.
And here's the thing you really need to take away from this. This transition is not just an environmental necessity, it is quite literally a multi-trillion-dollar wealth transfer. We are looking at the single most significant business and investment opportunity of our generation. Think about it. The EV sector needs a completely new global charging network built from scratch. Hydrogen requires the birth of a totally new global fuel supply chain, and the sheer number of advanced batteries we need to manufacture. It's staggering. The scale of capital deployment happening right now is completely historically unprecedented.
As we look ahead to that 2030 to 2050 window, this mix of tech and aggressive policy is going to fundamentally alter the human experience. Imagine living in a highly efficient smart city, seamlessly powered by clean baseloads and intelligent grids. We are shifting toward a reality marked by the absolute decline of fossil-dependent infrastructure and total renewable dominance. These urban environments won't just be zero emission, they're going to be noticeably quieter, much cleaner, and vastly more economically efficient.
When you think about it, humanity is essentially trying to engineer a completely new engine while the plane is still flying. It's incredibly complex, but the technological momentum pushing us toward Clean Energy 2.0 is undeniable. It's inevitable, as this massive shift completely rewires global markets, infrastructure, and your local economy. The question isn't if this will happen, but how. So as the energy blueprint of the planet gets actively rewritten, what role will your community and your investments play in the greatest technological revolution of our time?